driven by all of the data that we're collecting. How does that affect that? Like, I'm imagining it's going to create better environmental or those ESG values.
There is several aspects. For sure, as we were saying earlier, I have motion sensors across the building. That is LL88. It was an older local law, but still 97 is the latest of a series of building blocks that New York City has been putting there to get more and more towards the final goal of 2050 to be carbon neutral. So you use your motion sensors on your lighting.
What are some of the latest building technologies, such as AI, that are actually being used in today's buildings? In this episode, we're joined by Fabio Zaniboni, founder and CEO of BubblyNet and Chief Vision Officer at Zaniboni Lighting, to talk about how engineers can leverage emerging technologies to meet ever-evolving energy codes, improve building performance, and how smart systems are reshaping commercial spaces for well-being and sustainability. If you're a structural engineer looking to stay ahead of the curve, this conversation is packed with practical insights you won't want to miss. I'm your co-host, Matt Picardal.
And I'm your co-host, Alex Data, and this is the Structural Engineering Channel.
Transform your technical experts into impactful leaders with EMI's Engineering Leadership Accelerator. Tailored for AEC professionals, this program enhances communication, delegation, and decision-making skills. Flexible, interactive, and designed to fit your team's schedule. Elevate your team's leadership capabilities today. Visit engineeringmanagementinstitute.org and click on Corporate Training.
Fabio, can you tell our listeners a bit about your background and the path that led you to your current roles at BubblyNet and Zaniboni Lighting?
Yeah, sure. Engineer by education, between Europe, America, Africa, Asia, traveling the world. I've been working on over 40 different countries, got to learn the challenges and got fascinated about having different cultures and addressing problems from different angles. So for many years as an engineer, towards more the mechanical aspects, I was the VP at Comau, a very large robotics company, part of the Fiat group. And then from there, there was a dream that I kept on a drawer for too long. I say, I wish I could, challenge myself, getting to be an entrepreneur. And so I flew over the ocean, got to America. I was already working in the automotive, Detroit, Grand Rapids in the 90s. And I loved America. And I knew that if I wanted to start a business, the best country in the world would have been America. So I got here, I got into lighting and controls on yachts. Then I went to mega yachts, then went to cruise ships. Then I went to architectural lighting and then architectural controls. And fast forward 25 years, I'm here talking about BubblyNet. That is a latest dream come true.
That's quite the journey, and I like that you transitioned from the boats into the buildings. It sounds like you just kind of follow the path that makes the most sense to you at any given time.
Yes.
And I wanted to ask about, because at least in the building industries, I know you're in architectural industry as well. For structurals, I know there's a lot of talk about technology, AI, and whatnot. What do you see in maybe some of the lighting industry or some of the bigger picture industry, since you might have a bigger vision scope of what the future looks like? How do you see technology or AI affecting the future of our industry, maybe through some of our programs, or what do you see in the electrical industry as well?
Yes. Well, engineering is going to be revolutionized by AI. That's granted, is for sure. Last week I was at the AIA in Boston, and the keynote was AI, and we were talking AI from people at Autodesk to different manufacturers of structural ceilings and different applications. And the thing that is very interesting is that computing power is getting cheaper and cheaper. And electronics is getting smaller and smaller to the point in which you can pretty much embed anything you want any place. So you could embed vibration or inertia sensors on concrete. We embed nowadays sensors on lights, on HVAC, on thermostats, on air quality controllers, on accelerometers, all kind of different applications. And because you can push pretty much as much data as you want to the cloud, you can then take that data and start crossing the data, getting some very, very interesting applications. I will give you a few ideas. We launched a few months ago an AI module for HVAC. And what AI does is it start recording, of course, all the different parameters of the building, and start understanding what is the inertia of your building, what are the different coefficients of your building, start comparing outside temperatures, inside temperatures, because then that HVAC module is also connected to the lighting system where you have motion sensors. Now AI is able to start crossing information between which areas of the building are being occupied or which areas are not being occupied. And the load itself of how many people there are in the room can be measured in terms of the load that you get on your HVAC. We have also other technologies that are people counting. So you're going beyond, this room is occupied or this room is vacated, but you can get to a point in which, how many people there are in the room? And you can discussing human loads and so on. So what we did, and this model, the first test case was at California State University. The first model gave back about 30% saving on energy, and we're talking about 30% saving just because of software, just because of AI. We're not talking about anything else. So what this new level of computing power, this new level of being able to make a sense to data that before were totally disrelated, now are opening very interesting horizons where, engineering has always been very much siloed. You had mechanical, there was the silos, electrical, there was the silos, and then you have structural, there was the silos, and then you have plumbing, there was the silos. Well, of course, it had to be a silos because the human mind, there is so much horizon that you can have. There is so much broadband that you can get. Now with AI, you are able to go across multiple disciplines and start relating information that before it was almost impossible to relate. And so I really believe that we start with HVAC, we're progressing with lighting. There is an entire new category of challenges that we start embracing. And it has to do with the function of the building. It's almost like a reset and say, okay, let's think anew what a building is. And of course, if we're looking about office space or we're talking about multifamily and so on, well, a building has been roughly the same for the last couple of thousand years. You want to have a roof to protect you from the rain and the snow, and you want to have some walls and some windows, so you are kind of insulated from the exterior environment. And then you want to have some light, so you're not relying just on your circadian light, the light coming from the sun. Well, that was what we had at the time of the Greeks and the Romans. There is so much more that a building can do nowadays because we start understanding relationships between, for instance, oxygen levels or CO2 levels in a building and performance. And it can be performance in an office space where you increase productivity up to 15-20% just by making sure that you have all the oxygen that you need. But it could be also, what about recovering 15-20% faster from surgery on a healthcare environment? You can do that because you are addressing oxygen, you are addressing lack or existence of some specific spectrum, some lighting, like there is a specific frequency at 480 nanometers that is a cyan spectrum that the sun has in certain times of day, and it triggers on our photoreceptors on the body, triggers hormones like cortisol, that is our stress hormone, and then the lack of that frequency triggers melatonin, that, as we know, is the substance that then relax the body and help us sleeping well. So just on lighting, as you probably I've seen this on your brief. I have BubblyNet. I'm also still operational on Zaniboni Lighting. On the lighting side, we've been developing some LEDs, some microchips that can increase or decrease those specific frequencies. You're not going to see the difference on the light. The light is still white, and it has the same appearance, but you're just increasing or decreases those frequencies. And now you are able, I was mentioning earlier, to improve all these kind of factors. There is another very interesting study I was reading a couple of years ago from Berkeley. Sound distractions are reducing, and we're talking about between 7 to 15%, reducing learning speed on, a K to 12 or arithmetic lessons and so on, because the mind gets distracted, and you're no longer focusing, or you lose your train of calculation, thought, and so on. So now imagine, you address that now with sound masking. You're removing those distractions, and now you allow the occupants of the building to focus on the tasks they want to achieve. So there is the lighting. I was mentioning about the oxygen. We did tests here in the office. We did like typing test with higher or lower CO2 levels. And there is like your speed diminished as your CO2 increases. So now having a small embedded sensor that tells you, well, your CO2 is way above what it's supposed to be. And of course, you can go full in and have, fresh air intakes and having DAVs and so on. Or it could be, a very low budget application where now, and we're discussing this with a few California school districts, you have a little light where the sensor is that starts blinking red. Pretty much, you need to open two opposite windows for a minute, and 60% of your air is changed. So, the old grandma, good lessons, in the morning, open the windows of your room, there was a lot. It was not just grandma, trying to get some fresh air. Like, you sleep better, you study better, you do better what you want to do. So again, sorry, I took it a little bit too long, but yes, you are able to embed more and more intelligence, more and more data points at levels that were inconceivable a few years ago, because again, these microchips they're becoming cheaper and cheaper and less expensive, and really you can start. And then the other very important part is we are totally into the wireless space. So being able to connect these devices that can be battery powered, devices that can even be with we have kinetic devices. So just with the pressure, you get enough energy to send a Bluetooth message. We have devices that have little micro photocells. So you don't even need to have batteries to operate them. So it's like technology on the next 10 years in the building is going to give us some very interesting surprises.
Yeah, that was great. That was a really cool overview of all the possibilities that some of those I haven't even thought of. It's like it's kind of like the one that caught me was adjusting the lighting or the environment, the whole HVAC system to what you're doing in terms of, like you were saying, studying. There's probably some ideal biometrics that is probably ideal for that, or the environment in terms of what you can manipulate in the building. Yeah, it was all interesting. It kind of just feels like it's not just, oh, it's hot, turn on the air conditioning. It's, no, what are you trying to do? And all the technology around us gives us that data to come up with all these enhancements. Even that HVAC software that you were mentioning at the beginning, where they saved 30% just from software, just from gathering data. And I'm assuming that was in terms of efficiency or power usage. If someone's in the room, they don't need anything there, but if one or two or a whole group of people, it'll adjust it to what they need, right?
Absolutely, Matthew. And then what you can also do, now that you have all that intelligence, you can size your HVAC unit to a smaller size, because you size that unit because I'm going to have 300 people on a large conference room, and I need able to reduce my temperature, or I need to be able to address this load in so many minutes. Well, with AI, knowing, for instance, that you will have these 300 people in so many minutes, you can start, cooling down the environment, or with people counting, you don't wait for that load to take the humidity and the heat through the roof. You know that there is 300 people, and you know that in about 20 minutes it's going to feel horrible. So you start now cooling down. So now you don't need to have a huge piece of equipment that is able, now that everything is going through the boards, needs to now deal with the load plus, the load of the last 20 minutes, because you are able to predict what is going to be your load. So you have that. Yes, AI then can be totally pushed beyond just what we released a few months ago. BubblyNet, as the name, it was really when we started envisioning this kind of technology, and we say, well, we are going to be able to create your ideal bubble based on what you're trying to do. Are you trying to have fun? Like I was talking with an hotelier about future deployments on different hotels, and we were discussing specific tasks with beats per minute of the music. So you can, of course, you can understand that you have certain music that is the music that you're going to be willing, and it's going to be helping you out when you are out of breath during a CrossFit session. And then you're going to have a certain beats per minute when you are trying to wind down and try, or you're trying to relax, or you see. So as you do it with music, you can do it with the temperature of a room. You can do it with the lighting. Bluish lightings are going to be lightings that are a little bit more harsh, and they are stimulants, and you're gonna increase your metabolism. While when you have an ambery color, like it's what everybody has been experiencing. You are by a candlelight, or by a fire pit. Don't you feel that we are all friends? So you can recreate not only these kind of psychological effects, but you can create true biological effects that we read, like we do cortisol tests. We get blood tests, and we see how the body changes as your parameters within your building are changing. And it's going to happen with AI. It's going to happen super fast. Like experience, I have a Tesla X. Every time I get close to the car, the door opens automatically. I get on the car, the door closes. The seat, sets to my dimensions. Like we already know that. Why we cannot have that on a building? Like the building should recognize, oh, I'm European. I love my HVAC at 78. Everybody hates me. But if I'm like right now in my office, why do I need to freeze at 72? Like, look at how I'm dressed. I need to have a double coat at 72. So I get into my room, into my space. Well, the building should know I'm here. I live at 78, and HVAC should go automatically at 78. Why do I need every single time to go down? And you start seeing that also like in the hospitality, where now you are a Marriott, a frequent flyer, and you get to a room, and there are a few properties that started having that, and the room recognizes you and knows exactly, what are your settings that you want. Like thinking about a building almost like a breathing organism is fascinating to me. Yeah.
I was also wondering, because that's got me thinking too, and I think some of the structural applications, I think you kind of mentioned it too, like accelerometers installed in some of the buildings on some floors. I've been taking that step further, because with all of that, I know at least for structural engineers, for let's say an earthquake happens, like that's valuable real-time data that we can use not only to make sure that the building is still safe after an earthquake, but it gives us that real life data in terms of, because with buildings we can't make a prototype and test it on an earthquake table. We're building that thing. There's no prototypes, and we have to rely on our computer models to do that. And then having that real time data or that actual real world applications, I know that's very valuable, at least for the seismic community.
Absolutely.
And yeah, I'm thinking like vibrations too.
Yeah, those kind of sensors, of course, Matthew, I believe that what we do as engineers is, of course, we're doing the task that we are assigned, and we're going to build that building the right way and so on. but we're standing on giants shoulders. So we should do the same. And embedding sensors on my current building, let's assume that that information is not going to be valuable for my building. For sure, it's going to be valuable for the next generation. That thanks to those data is going to be able to build a better building. So we can think about how we can future-proof our buildings, or how we can future-proof our design by experiencing, like we never experienced before, buildings under stress. But there is also a lot of things that you can do in real time. So you put these sensors, and now you could trigger an event. Like we have what are called events, scenes. We call them in different ways, in different disciplines. But let's say that you have an event that is an earthquake. Well, instantly, you should have all your elevators going down to ground zero on a break or whatever it is, and you should start locking down water pumps or start triggering your emergency circuit. There is so many things you can do just because you have a vibration, and now you are able to recognize, well, there is something beyond the standard performance of this building, and now we go on an emergency status. It cannot be just an emergency status just because we have a fire. Of course, we have fire detectors, but we can address and we can improve the safety just because it is not like, oh, there is a earthquake, now there is panic. Now everybody's trying to go towards the exit, and now we have all the exits overloads. Like in those events, the seconds are the difference between, there could be the difference between life and death. So you can do a lot of things that are becoming very, very interesting just because you have several seconds before there is the physical recognition from the occupants of the building that a earthquake is ongoing. And we use all these kind of vibration sensors and accelerometers and so on. We do them, of course, on pumps, on different kind of equipment. So because as you know, like, you can kind of determine the lifetime expectancy based on temperature and vibration. So, of course, as a motor is going up in temperature and is going up on vibration, you know that there is so much life expectancy that you can expect from that unit. So, yes, definitely, we're just chatting, but I'm sure that if the community, the structural community, start thinking, okay, what could I do? Like, what results just by merging electronics, sensing with structural? I think I'm sure somebody will come up with some great idea.
Yeah, one that just popped into my head. It's not revolutionary, but I've seen those videos where there's a sports stadium or a crowd, and they're jumping up and down in unison. And as a structural engineer, like, no,
please don't do it.
Take that time of stop jumping. There should be some type of alarm. I don't know, the fire alarm goes off or something, like, stop. Everything stop.
Can you imagine the engineer that designed that stadium? How he feels?
Oh no. It's like, I think you should see the whole thing jumping up and down. But yeah, that's just came to my mind.
It makes you thankful for the safety factors we use. So that actually brought up a thought that I was kind of throwing around. I mean, in the structural realm, structural health monitoring is becoming a bigger and bigger topic. And I think if you combine it with AI and some of the sensors you're talking about, I could see it as an alternate method of actually confirming structural designs. I mean, when we design a building for, say, a seismic case, we're tuning it so loads go where we expect, and we kind of like the stadium talk. We're looking at the resonant frequencies of the building, and I think even with a small event or enough occupancy in the building, you could start to pull some of that data out if you could actually process the data.
Absolutely, and with AI, like, if you embed those sensors, the sensors are wireless. It costs a fraction of what it used to cost when you had to Cat 5 or Cat 6, all the different sensors to a panel, and the panel to a central panel. So everything is smaller and easier. And now you start having heat maps on your building, how it behaves. And so you will have that structural engineer that designed that stadium, instead of saying, no, please don't do it, say, yes, please do it, because I'm seeing here on my desk, on my desktop, exactly how my baby is behaving. And then all that information, that becomes value for whomever developed that building, because you develop a building, you put the sensors, and now you have it, like the example Matthew that you were mentioning, everybody, jumping. Now you start seeing on your digital twin how the structure is performing based on that load. You are learning something that who else will demo a stadium and put 5,000 people and say please jump to see what's happening. So you can use a real life experience to learn more about how buildings behave for future projects.
Data like that, I mean, it could help us discover gaps in the code. Maybe we were designing too conservatively in some areas and maybe unconservatively in others. And I think with AI ingrained with all that type of data, we can start to identify ways to improve as well.
Totally agree.
Have you used it in any, I guess, with technology? I know during the design process for, at least for structural, I mean, there's a lot of, the complex software programs that go into doing a building model. I'm sure there's applications there. Have you seen that also in your industry in terms of software? I know you mentioned like Autodesk. Like, did you have visions on what they could do in terms of software capabilities?
Yes, I'm start seeing big divide. I start seeing, unfortunately, legacy companies that have this approach to AI like is not ready. And I totally agree with you. In many applications, AI is not ready. But if you do not embrace AI now, you are not going to be ready when AI is ready, because it's a big learning process. Like every month, we have different challenges within the company. And once a month, we award whomever got up with the best AI application or save the company the most money quarterly with AI and so on. And it's a process. I'm old enough to learn to use a computer after the university. And, I was still younger, so it was pretty easy. But, I can imagine, like, if you would ask an engineer that never saw a computer for the last 40 years, or my predecessors, they were still using, those punching cards on the old big cabinets at the university, where you spend an afternoon, with your briefcase of punching cards. Like, those engineers to start using new software, and particularly like a graphical interfaces and so on, it was kind of a big leap. Well, the leap from non-AI to AI is bigger than any leap I've been experienced. Bigger than your smartphone, bigger than your desktop or laptop. And it takes some time. You need to retrain almost your reasoning. The reasoning is about how you're going to prompt your question. The reasoning is how you're going to build those buckets of data so that you can get the right information. Because AI is still, you have junk in, junk out. So it really depends, how you prep this super engine in order to deliver what you tend to be delivered. So back to your question, I do believe that, in the next 5 years, we're going to see a disruption. We're going to see startups. We're going to see relatively newer companies that are still on kind of startup mode, surpassing and getting into leading positions against companies that were reluctant to adopt this technology. And then, of course, we are going to see very large companies. I'm seeing them right now without naming names, that they already have a leadership position and they are embracing AI. And I don't know how competition are going to be able to compete with these behemoths that now have also AI on their side. So it's happening very fast. And it is not an evolution that you can stay on the sidelines and keep score. It's not going to work.
Yeah, it's not ready in most applications, but just thinking of like what it can just do from now until people actually invest more money and time into it. I mean, yeah, all those companies, they're investing a lot of money into AI now. And what will that look like in 5 years?
Yeah, I will give you an example. My son works on the lighting company, and he used Gemini and created a gem, trained it with all the spec sheets and all the data information, the IS files that are the files that represent the beam of the light. And after he loaded all this information, he started asking questions. Okay, how many feet on center I need to install this specific product on a hallway, like ceiling of this height, this width, this material, and I want to have so many foot candles on the floor. Before, you would have a lighting designer spending a couple of hours doing that. And he got his information in 15 seconds. So it's happening fast. It's happening very fast. So I agree with you, Matthew. I keep on having. I will not get into the details because it's not very nice for the different AI providers. But it happened more than once. You really you sniff it and say, no, it cannot be the right answer, and you challenge the answer, and then you get the AI saying, "Thank you, good catch." I missed that multiplication factor. And you're like, thanks. So don't use AI just to do your cards for structure, like bridge structural, performance. We're not there for sure, but we're gonna get there. Like in the software side, I would say that our coders, I would say that they increase so far their productivity by at least 30% with AI. So I'm pretty sure that also engineers, structural engineers, they can start using some of these tools, and they can start cutting those low-level tasks that were just quote unquote wasting their time.
Yeah, on the low level, I mean, even just helping with spreadsheets, it's a huge time saver if you know how to use it, and that's like low level fruit. But then, what else can you do with it, right? It just goes up from there. But always being careful. I know it's not ready for all the math and engineering side. You'll see some, like you were saying, you'll see some errors, and like, it's not there yet, but it was a good try. So next time.
So what are some of the common misconceptions about wireless versus wired building control systems, and how does mesh technology challenge those assumptions?
I like this question. We did a few years ago one of the largest cybersecurity companies here in the US project, and we were discussing wireless versus wired. And there's almost the analogy of, you remember about 15 years ago, everybody had an in-house server and multiple IT people, because there is nothing safer than to have our own server in the basement. How many companies do that nowadays? You have everything on the cloud, and when you would pitch, you should put everything on the cloud. It's much easier. You don't have the downtime waiting for the external IT person to come from outside town or whatever. It was like, well, but on the cloud is not secure. Well, it turns out that probably the cloud is way, way more secure than to have it on the basement. And similarly on wireless, there is this misconception, yes, because you have protocols that are easy to interfere with. You have protocols that are easy to hack. You have a ton of old Wi-Fi routers that hackers, have a picnic with. But for instance, what we use is 256-bit encryption end-to-end. It has 15 different layers of security. It's still part of your open platform, Bluetooth, but it's what is called Bluetooth NLC. That is the latest version, is the 2023 version. And just to give you, so it's fully encrypted, but has a wide variety of extra security compared to the Bluetooth you have on your phone. Like you have your Bluetooth on your phone, somebody needs a message, even if it's encrypted, I can always replay the message and do exactly what you were doing when you were playing when you were creating the message, because the message is still the same. In our case, in Bluetooth NLC, what you have is that every message has a unique encryption key, and the encryption keys keep on changing, almost like with a counter. So even if you grab, somebody turns off the lights of the entire building and say, I'm going to start having a denial of service attack tomorrow, and I'm going to turn off all the lights of the hospital or whatever. Well, if you try to send that same message later on, the network it sees that the encryption key is an old one, and automatically discards the message and blacklists the unique ID of the device that was trying to enter and to hack the network. So yes, people think, if it's copper, if it's inside the wire, nobody can get there. Well, relatively true, because you can always go on LinkedIn, see what are the job openings, apply for any kind of job, get to a meeting room and unplug one of those, conference call speakers on the Cat5. You plug it into your computer, and if you know what you do, you are into the system in a matter of seconds. So yes, there is this appearance of copper being more protected, but unfortunately, because people think, it's protected now, they're not protecting it from the inside because they don't thinking about an attack from inside. And then they leave open, we were talking about Wi-Fi, they have a router someplace connected with, whatever kind of service, and the router sits there for the next 10 years. Now you have a system that is 10 years old. And all our software, all our gateways and so on, they continuously getting updated, so that the security is getting updated, everything gets updated, because, of course, the challenges, the cybersecurity challenges, they keep on updating. And if they update and your system doesn't update, guess who's going to win sooner or later? So wireless, it has this perception of, it's easier to hack, as reality is not. We've been doing federal buildings, we've been doing airports, projects, and like airports is the typical, in an airport you have tens of thousands of passengers on their Bluetooth. And if you have an airport saying, okay, I'm cool with this technology, it means that the technology is good. We, for airports or sensitive sites, what we do is what is called an air gap system. So it's a system that is end-to-end encrypted, and there is no back doors really you can use to enter the system. So yes, for sure, between wireless technology of 10, 15 years ago and wired, I would say wired, when we're talking about what is happening in 2025 on the wireless space, I prefer many wireless solutions than the hardwired. Also because, the wireless, it's wireless, you can update it over the air. So you have a continuously evolving system in a world that is in very fast, accelerated evolution. So you have something that is hardware-based. That hardware is going to stay there for 15 years. And after a few years, it's going to be obsolete, and it's going to give you a surface of attack that is going to be much higher than a wireless system that continuously updates itself.
Wow. I wanted to ask one more question on my end. I know because conversation is really cool, but I know we want to be respectful of everyone's time. So my last question had to do with some of the sustainability carbon targets of, like, for example, I believe New York City has a local law 97 where we have ambitious carbon targets. How do these smart technologies, driven by all of the data that we're collecting, how does that affect that? Like, I'm imagining it's going to create better environmental or those ESG values.
Absolutely. To the point in which for LL97, we design a specific software and specific website is, you find it at reinvent NYC, New York City.com. But anyway, so over there is a lot of very, very cool information about, how to get LL97 compliant. And there is several aspects, Matthew. For sure, as we were saying earlier, I have motion sensors all across the building. That is, I think it was LL88, was an older local law, but still 97 is the latest of a series of building blocks that New York City has been putting there to get more and more towards the final goal of 2050 to be total carbon neutral. And so you use your motion sensors on your lighting to, of course, turn off the lighting, but also after so many minutes, in getting your HVAC at a higher temperature. It's called the setback temperature. So there is many things that you can do in order to reduce your greenhouse emissions. One aspect I want to mention that is very important, unfortunately, ESG over the years got kind of tinted because of what in jargon we call greenwashing. So players putting a facade and saying, oh, whatever, and buying carbon credits or whatever. And now all of a sudden they are complying with their targets and the green emissions and so on. And it's typically a PR facade. There is no really concrete action. So the beauty of technology is that we have a full cloud system that collects all this information, makes it represent it on graph, can take that information and give actionable, data, can also have these AI models I was mentioning earlier. So instead of having, this information being digested by a facility manager, you can have an agentic AI that takes control of parts of your building or parameters of your building to optimize that greenhouse emissions. I think it's very important to have this IoT and to have all these sensors and to have a respected company putting on the cloud this information, because it's not information that's going to be biased. It's not information that can be in any way altered. And so if you say, okay, this is my baseline, and on the last 5 years, I reduced 25% my greenhouse emissions, well, if you have a third party that has been measuring, day after day, hour after hour, month, year after year, and we have ton of information from, all the different areas for all the different, data points and so on, and it's totally demonstrable that you have been doing that, you overcome possible gray area of this greenwashing. And sometimes people say, yeah, but it's all fake. Yes, but it's not true. Yes, but it's too expensive. Like, data are data. We are engineers. If you invest $250,000 on a project and then you have a return on investment of $120,000 a year in just power and energy, and your return on investment is so much, and you are doing so good for your environment, that is not opinion. And so I think it's very important for ESG target, for the importance of the trajectory of really getting cities clean and environment cleaner than the environment that we have been leaving behind us for the last, probably 30, 40 years. It's important to have a technology that can absolutely guarantee you, yes, these are the data, these are the information, and this is the progress that we did so far.
Yeah, that's awesome. It's the data. It's there. It's not you buy a product and it has a rating. Maybe that might not be true. Maybe based on hand calcs, but at least with the data, it's real time, 24/7, ideally, and you have the data. It's true. That's pretty cool.
It is.
Yeah, data kind of helps weed out the opinion and there's uncertainty when you're looking at, trying to make your building greener and what actually has an effect in the long run and how it's all going to pencil out. But you can't really argue with hard data. So I really appreciate that.
Exactly.
And I think we're moving towards the end of this. So I wanted to ask, what's one final piece of advice you'd like to share with structural engineers looking to innovate in building design and operations?
There is a lot of very interesting technology out there. And as an engineer, it's fascinating how every time there is a new technology, you go through this phase of the excitement of seeing the technology, dipping your toe, realizing you are definitely out of your comfort zone, withdrawing, saying, I'm not going to do it. And then you say, no, I want to be cutting edge. I really need to do that. And then you push down and you get on your entire feet. And finally, you take the big jump and you start adopting the technology. So let's embrace, newer technologies and let's experiment. As we were saying earlier, sometimes technologies are not ready. It's the price that we pay as early adopters, but there is a pride in being early adopter. Sometimes you look like kind of silly to others, but it's thanks to early adopters that then technology gets mainstream. So let's be early adopters. Let's have some guts, and help the followers to get where we have better technology and better structures.
It's great advice.
Yeah. Well, but That was certainly very interesting. You have a lot of really interesting information that I got to wrap my head around it, because we've been looking at structural health monitoring even a little bit on my team. So I might be giving you a call down the road.
Very good. And if I can help in any way, Alex, I'm here.
Thanks so much. Yeah, that was really cool. Thanks for sharing your vision. Thanks for sharing your insights and for the really insightful conversation. That was really interesting to see what possibilities there are in terms of technology and AI. So definitely appreciate it.
I hope you enjoyed today's episode. We would love to hear your feedback, comments, or questions. To leave them, please visit structuralengineeringchannel.com. There you will find a summary of key points, as well as the links to any of the resources or websites mentioned during the episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. And until next time, we wish you the best in all your structural engineering endeavors.